Okay, Assalamualaikum and good morning, everyone.
Waalaikumsalam warahmatullah.
Salam.
Waalaikumsalam.
Okay, so we will continue on our lecture on lecture for diffusion model, and then if we have enough time, we will discuss assignment 2B. Okay, so uh, last week we have discussed the example tutorial 1, electrical signals in the heart. So there are two types of equation. You have Fizeau-Nagumo and also Landau-Ginzburg. So you can try the second equation, because last week we only managed to do the Fizeau-Nagumo model. Okay, so for this week, we will go into learning another example of diffusion model, but this time we are going to learn on oxygen diffusion in myocyte. Okay, so myocyte basically is the muscle of the heart. So our heart is a muscle because it can contract and relax. So it's a muscle. It's a different type of muscle, not the same as our bicep or tricep, quadricep. It's called the myocyte. Okay, so the myocyte is for our body, like muscle, myocyte. It's all of them are cells or tissues. So all of them requires oxygen. If the oxygen supply is disrupted, maybe due to blockage in the artery that supplies the blood to the muscle, then the cell can death. Okay, it can cause cell death via necrosis. So necrosis is cell death due to disease, or by apoptosis. Apoptosis is the cell death, meaning that the cell kill itself because the environment is not suitable for it to live anymore. So we can model the cell death by using diffusion equation. And our heart or myocyte is supplied by oxygen through coronary arteries. So if you look at this figure, the coronary arteries, I think is not in this figure, but this saluran darah here supplies oxygen to the heart. So the heart, as you know, pumps blood to the whole body, but the blood also requires oxygen or requires blood. So dia macam interconnected macam tu, macam inception macam tu. Because the heart itself is an organ or cells yang memerlukan oxygen dan memerlukan darah. So our heart, even though its function is to pump blood to other organs or tissue, it itself is an organ, so it requires oxygen, which are supplied by coronary blood vessels. So a simple diffusion model is given by this equation here. Del CO2 divided by del T, oh my god, del CO2 del T equals DO2 del squared CO2 plus QO2. So CO2 is the oxygen concentration, DO2 is the oxygen diffusion coefficient, and QO2 is the oxygen source given by this function here. So we can use the general form PDE solver in COMSOL to code this and run some simulation on oxygen diffusion. Okay, so another like the boundary condition for this model, we can assume that in the normal tissue, the concentration of the oxygen equals 1 or 100%. Okay, for damaged tissue, abnormal tissue, we can assume that the concentration is less than 1. So in this case, in this example, we use 0.1, meaning that the region with damaged damaged myocyte has only about 10% of oxygen. So we can use this concept to represent blockage in coronary artery that causes cell death in the myocyte. So blockage of artery, blockage of blood vessel, we call it ischemia. So kalau dalam dunia nyata, selalunya kita dengar orang sakit jantung, orang kena stroke. So orang yang sakit jantung dan stroke ni selalunya salah satu saluran darah dia tersumbat, okay? Tersumbat disebabkan maybe kolesterol or blood clot or maybe ada apa-apa yang menyebabkan saluran darah tersumbat. So bila tersumbat, dia menyebabkan aliran darah tu tak boleh nak lalu dengan sepenuhnya, okay? So when the blood cannot flow perfectly or cannot flow because of those blockage, then the surrounding cells will not receive the required oxygen and nutrient. So the surrounding cell will start to die, okay? So bila sel ni mati, ni menyebabkan jantung kita pumping lemah, orang kena stroke, macam separuh badan lumpuh semua tu. Okay, so in this example, we can draw a heart using an ellipse shape. And because this simulation, the heart is ellipse, so it's like a revolving structure. So to simplify the simulation, we can use 2D axis symmetry concept. Okay, so we will look at what is axis symmetry. Okay, and then after that, we can mesh the geometry. So here, before that, in the heart, we have two regions. So the middle one here is abnormal region, okay? Kawasan yang sel dah mati tadi. The remaining parts here are normal region. So we can mesh the abnormal region using finer mesh, and the normal region mesh dia besar sikit untuk jimatkan RAM. And then this is the study settings. And this is an example of results. So kita boleh nampak lah kat tengah ni oksigen dia kurang, tapi as the time goes, oksigen tu akan bertambah. Tapi ni tak nampak lah time dia. Okay, so we can try using console. Okay? So ada instruction. So let's do this together. Okay, so firstly, open console. Choose model wizard. And then choose 2D axis symmetry. Okay, so kita ada, last week we learned about 3D. So this week we learned about 2D axis symmetry. So if you look at this diagram here, tak besar pun sama je. Okay, kalau nampak bentuk ni dia macam cylinder ni, dia revolving around an axis, okay? So because the shape of our heart here is revolving around a center axis here, then we can only simulate the 2D cross section here untuk jimatkan simulation time semua dan simulation RAM semua tu. So we can use 2D axis symmetry. Okay, after that, we have to select the physics. So we choose general form PDE. Okay, and then go to study, and time dependent. So just double click. Okay, and then we go to parameters. So parameters 1 here. So kita letak name and expression given here. Okay, so when you put unit in console, you must have the square bracket, okay, to put unit. So if you use a circle bracket, then console will not be able to read the unit, okay. Then after that, in definition, so definition here, go to variable. So you can go to definition on top here and click local variables, or you can also right click on definition in the model builder window here and choose variable. You will get the same thing, okay. And then here you write the name and expression given. So firstly is KO2 and QO2. Okay, so kita akan dapat yellow kat sini sebab kita tak define lagi CO2. Okay, geometry kita tunggu jap. And then we go to general form PDE. So in general form PDE, change the unit source term quantity to 1/second. So source term quantity here. So just change to 1/second. And then dependent variables. So open this section and field name CO2, dependent variables CO2 juga. Okay, so just replace here. Okay, so dalam example ni, we are solving for CO2, meaning that concentration of oxygen. So when you replace this CO2 here, then you go back to variables 1, then the yellow has gone, okay? Okay, so kita pergi dekat geometry pula. Okay, so we need to develop this geometry in console, okay? So firstly, you need to draw there are two ellipse here yang dah dipotong, okay? So two ellipse, one ellipse, the internal ellipse, and another one is external ellipse. Lepas tu kita potong dia. So we draw the ellipse first. So right click geometry, or you can go here, geometry, primitive, ellipse, okay? So here, we draw the external first. So the external axis, I think A axis is 0.037. Okay, and then the B axis is 0.047. Okay, so kita dapat external ellipse. And then we draw the internal ellipse. So boleh duplicate ataupun you can choose new ellipse. So the berapa banyak ni? Okay, so ni dia punya ketebalan, okay. So for the A axis, it's 0.037 minus 0.012. And for the B axis, 0.017. 0.047 minus 0.012. Okay, lebih kurang macam ni lah. And then we need to cut the ellipse to get this shape, okay? So assume that this is 1/4, 1/4, okay? So to cut, first we need to create a block. So the first block kita nak cut yang belah kiri ni dulu. So kita nak cut belah kiri. So we change the corner, maybe somewhere here, okay? And kita kecilkan length. Tukarlah rectangle. Okay, so kita guna kita guna rectangle, okay? So kita nak cut yang sebelah kiri dulu. And then after that, kita nak potong yang belah atas pula. So we use another rectangle. So we change the corner to 0, maybe somewhere here. Okay. So kita dah cover, kita tinggalkan yang ni je. Okay, after that then we can use Boolean transformation difference. So object to add is this, the external ellipse. So object to subtract is yang block dengan internal ellipse. Tak apa, try dulu, tengok betul tak. Okay lah, boleh lah, jadi lah. Tapi lain sikit shape dia ni, lupa dah lukisan dia kenapa macam ni. Tak apalah, ni example je. Okay. After that we draw the abnormal region here. So we use rectangle. So the rectangle height is 0.01. So kita turunkan dia sikit, maybe somewhere around here, negative 0.015. Okay, bawah lagi kot. Boleh lah. And then we intersect. Intersect both of them to get the abnormal region. But if you use the intersection, then semua geometri akan hilang, hanya akan dapat 4 segi tengah ni je. So to avoid that, we choose keep input object. Okay, so kita dah ada intersection kat tengah ni. So the next step is to delete the remaining rectangle here. So delete. So you get the something similar to this, okay? Walaupun tak sama. Then you can build all. Okay, and then dah lukis geometry, then we can continue the steps given here. So the next step is to write the codes in general form PDE1. So in the general form PDE1, so in the conservative flux, you write PO2 times CO2R, CO2 times CO2Z. So kenapa kita tulis DO2 CO2 ni? Because in the equation given, you have this section here, del squared. So you need to compare this equation with the equation in COMSOL. And since tau here is with del, so you need to write DO2 times CO2R. Okay, DO2 yang ni, CO2R is the remaining del CO2. Okay, so sama macam konsep tutorials minggu lepas. And then after that, you write source term QO2. And then in the initial values, choose normal region. Okay, so kita kena right click and choose initial values. So initial values 2, you choose the abnormal region. So just click the abnormal region and enter here 0.1. So automatically in initial values 1, it will override the domain number 2 because domain number 2 is used in initial values number 2. So here you put 1, okay? And then in the mesh, so we can mesh the abnormal region final and the remaining region as normal mesh. So what you need to do is right click, choose free triangular, and then choose the abnormal region. So first you need to change this to domain and then choose abnormal region. And then right click free triangular, choose size, and then change here redefine as final. Then we can try build. So ni dia punya mesh kat sini. And then repeat the same step. Free triangular, remaining means region yang tak mesh lagi. Right click, size, normal, okay. Then we build. Okay, so kalau boleh tengok kat mesh ni, yang tengah ni lebih halus berbanding the normal region. And then lastly, we go to study. So we don't change anything here. The time range is the same and we just compute. Okay, so cepat je sepatutnya. So kita akan dapat result yang sama macam macam ni, okay. And then we can also look at the revolution dia. So yang ni dia punya revolution. Revolution means that tadi kita solve only the cross section. So when you plot the 3D plot, it will show the revolution, okay. So you can see here the revolution 2D, okay. So you can also change how much degree of rotation or of revolution you want to plot by going to dataset and here revolution 2D. So in here you can change the angle. So maybe you want to plot completely from 0 to 360 for example. So kita akan dapat plot dia nanti yang 3D penuh lah. So you can also change if you want to see the heart to cut the heart, okay, to see the results in the middle. So you can plot maybe until maybe 270 for example. If you plot, then bolehlah nampak result dekat tengah-tengah ni macam mana pattern dia. Okay, so you can also play around with other plots. Okay, there are so many plots. Boleh cuba-cuba. Okay. Okay, so that's it for lecture number 4. So sebelum kita discuss assignment, kena bagi assignment 3 pula. Okay, so assignment 3 basically saya nak korang just follow je yang dalam buku ni. Okay, dalam buku page 217 example 6.2.2. Okay, so just follow this example. There are steps given already. So dalam example ni dia nak tunjuk macam mana nak simulate electrical signal juga dalam jantung, tapi model dia Rogers-McCulloch. Okay, Rogers-McCulloch PDE formulations. So nanti bila simulate dekat 4 segi ni, so boleh nampak dia macam mana results dia lah. Okay, so dia punya action potential dia. Okay, so that's it for lecture number 4. So assignment 3 minggu depan hantar, okay? Hari Ahad macam biasa. Okay, so let's discuss your assignment 2B. Okay, so Matt dah tak buka lagi. Okay, assignment 2B adalah model yang digunakan untuk study COVID-19, okay. Bukanlah model yang complete. So model COVID-19 tu ada banyak jenis, okay. So one of the example here has only 3 ODE. There are 3 ODEs only, but a more complex COVID-19 model, dia ada banyak lagi ODE. Okay, kita boleh study population orang yang ada virus tapi tak tunjukkan simptom, for example, population orang yang ada virus dan ada simptom. So dia ada banyak lagi equation dia. Macam ni yang paling simple model for pandemic or epidemic model yang paling simple, hanya ada 3 equation saja. Okay, so let's see what the question is about. So mathematical model to describe COVID-19 outbreak in the population is as shown below. So S, I, and R represent susceptible, infected, and recovered from virus. So the parameters del represents the ratio of recovered people become susceptible again. Maksudnya orang yang dah recover boleh kena balik virus yang sama. So the value of parameters are beta 2.18 times 10 power of minus 3, gamma 0.4404, and that is 0.03. So question A, simulate the model using initial condition S naught 762, I naught equals 1, and R naught equals 0 for time from 0 till 60. Okay, so let's write the equation, the code, okay, the mallet code. So the first function that you need to write is the ODE function. Tiba-tiba start, nampak? Oh. So you can name this function maybe ODE COVID-19. So first thing that you need to do is to write dy dt equals zeros. So you have three equations, so 3, 1, okay? And then after that, you need to write the parameters involved. So first is beta. And gamma and delta. Okay, after you write the parameters, then you can write the ODE equation. So to avoid confusion, we write y1 equals s. Okay, so dy dt1, the first equation, is negative beta times y1 times y2 plus delta times y3. Second equation, beta times y1 times y2 minus gamma times y2. And lastly, gamma times y2 minus delta times y3. Okay, check macam semua betul, okay? Then we create the calling function, okay? So function so here we name your function as this, okay? Q2A MA your matrix number, okay? So Q2A MA So in the calling function, first thing that you need to do is to define the initial conditions. So initial condition is 762, 1, and 0. Okay, so yang ni, the first one represent the initial condition for S, second one for I, the third one for R, okay? And then after that, you write your time span from 0 260. Then you can write your ODE solver. So first thing is call the function COVID-19. And then the time spent, and why not? And then save dulu. And then try run or try copy. Undefined, okay. Okay, so dia berfungsi, okay. Okay, so maknanya soalan A dah dapat lah, okay. And then we go to question B. So question B, plot the SIR against time in one single plot using different colors. Okay, so before that we separate them, okay. So S equals Y1, I equals Y the second one, and R equals Y the third one. And then we can plot E tengok dulu boleh tak? Okay, so kita akan dapat satu graf kat sini. Untuk question B. So the next question in question B, then from the plots determine the time when I reaches maximum. So I yang mana dah? So kita letak legend. Legend. Okay, plot balik. So I yang color merah. So the time when I reaches maximum. So anggaran je lah, okay. So the time is about, boleh picit je sebenarnya. So the time is about 6.3, okay. So you can write in the comment. Okay, dapatlah soalan B selesai. Okay, the next question. In a different population, the recovered group may not become susceptible to COVID-19 again. So write new code to modify the model using the same criteria in A, repeat process in B, and then comment the difference. So apa yang perlu buat ialah copy paste. Okay, dah copy, kita tukar nama je kat sini. Question C. Save dulu. Okay, and then we need to modify something. So here the recovered group may not become susceptible to COVID-19. So clue ada kat sini dah. The parameters del represent the ratio of recovered people become susceptible again. So kalau recovered group may not become susceptible, meaning that del equals 0, okay? So just change here, del equals 0. And then save and run. So you get a new graph. And then repeat process in B. So cari I maximum ni kot. So somewhere around 6.3 juga. Okay. Okay, and then comment the differences between the two simulations. Alah, dah delete. Run balik. So kalau yang tadi dia punya graph dia macam ada rippling, dia tak reach steady state. But for the second question C, the value of S and R and I reaches a steady state value. So mungkin kita boleh komen kat sini yang kalau ada population yang recovered boleh kena COVID-19 balik, so dia tak akan reach steady state, dia akan macam ada ripple. So ripple kat sini somehow macam show there's a chance that COVID-19 boleh bertambah balik dia punya jumlahnya pesakit dia. Tapi dalam question C ni, bila orang yang recovered tak boleh kena COVID-19 lagi, dia reach steady state, meaning that tak mungkin jumlah COVID-19 ni akan naik balik, okay? Dia akan sampai this value lah, okay? Maksudnya dia akan steady maybe around 1 here. So untuk question ni requires your skill untuk discuss lah, okay? That's why dia 10 markah. So maybe you can say from question A, the S, I, and R do not reach. Mana-manalah komen, okay? Dapatlah markah, 2 markah ke 3 markah kat sini. Okay, so itu saja untuk hari ini. So, any question? Hai. Kenapa angkat tangan?
Sir, esok berapa soalan?
So, esok ada 2 soalan.
Okay.
Soalan pertama dari assignment 1, assignment 1 yang kena buat function tu dalam 15 markah. Soalan kedua assignment 2 macam assignment 2B ni tu 35 markah. So total 50 markah, nanti convert jadi 20%.
Oh, okay doktor.
So
Banyak ke?
tak banyak pun, 20% je.
Oh, minit sir.
So kita start pukul 8. Sejam 45 minit. Boleh je. Soalan satu tu setengah jam siap kot. Soalan dua tu sejam. Sejam suku. Coding je, tak payah kira.
Start pukul 8 tu susah.
Masa 2 jam terus.
Start pukul 8, nak start 8.30 pun boleh.
Okey juga tu.
Time penalty tiba.
Takut bangun lewat je pukul 8 tu.
Tak apalah, bangun pukul 9 pun tak apa.
Hujan sedap tidur je.
Harap-harap hujan kan. Kalau hujan
Jangan
best sikit.
Sambut tidur sir.
Okey je, selalu sempat je. 10 minit siap. Soalan satu lah, 10 minit siap. Soalan 2, 15 minit. So okey lah, sejam 45 minit.
Tak coding dalam apa ni sampai dalam ni .m.
.m je. Nanti saya buat submission, just upload kat situ je. Nanti arahan dia lebih kurang macam ni lah. Q2A, macam tu, Q2C.
Kalau sama enggak copy paste lah.
Tak, soalan dia lain. Bukanlah macam ni. Copy paste ni je. Arahan je.
Macam susah je punya ODE tu.
Tak, ODE dia simple je. Lagi sikit dari ni, ada 2 je. Tapi equation dia panjang jugalah.
Okey, nampak.
Lepas tu parameter dia banyak sikit. Lepas
Banyak.
tu soalan dia sebab dia orang suruh pecah kan, macam plot ni. Macam soalan B ni ada 2 soalan, so dia orang suruh pecah kan. Jadi nampak macam banyak soalan lah.
Yang tu lama.
Macam mana?
Sir.
Ya, nak tanya apa?
Dia kan, tahu lah kalau equation tu panjang kan. Kalau equation panjang tu, macam ada bahagi darab tu semua kan. So, kalau kita tak letak bracket, dia tak effect.
Macam CP dululah, adalah efek. Tapi macam yang ni kan. Tapi yang ni lupa nak letak dot. Okay, letak dot pun boleh, tak letak pun sama je. Asalkan bila plot tu jawapan dia betul tu je.
Takut kalau tak letak bracket dia jadi lain, jawapan dia sama je.
Tengok susunan lah, kalau ada pecahan contohnya, ada fractions. So kena make sure ada bracket yang betul lah. Esok ada fractions. Dah clue.
Kalau dot tu ada lebih. Ada tu tiba kena ada pula.
Itulah macam ni tak payah dot pun. Tapi sepatutnya tak payah pun tak apa. Sepatutnya. Tapi kalau rasa risau, buat je lah dot. Semua buat dot pun okey. Letak dot. Letak dot. Letak. Nak bagi puas hati. Letak. Letak.
Leceh je. Satu.
Tak apa. Okey je. Type laju sikit.
Okay.
Type WhatsApp boleh laju.
WhatsApp atas stiker.
Deep.
Kan? Atas stiker laju je. Okay, so any question, mungkin boleh tengok balik assignment 2A, 2B dengan assignment 1, okay? Try fahamkan konsep, especially soalan C ni. apa kena tukar. Soalan C ni, bila nak jawab soalan C, pastikan soalan A dengan B ni betul dululah. Okay, selalunya kalau A dengan B betul, C ni memang senang je. Macam tak payah.
Kena betul saya.
Kena betul lah. Okay, and then understand how to write two functions. Function pertama, the ODE function, and then the second one is the solver function, okay, or calling function. Okay, itu je. So, is the comment open-ended question? Open-ended, tapi make sure you comment something yang make sense lah. For example, like here, question C, comment on the difference between the two simulation. Maybe if you answer simulation question A a bit slower than questions 2C, tu macam tak logik macam apa ni. So comment based on the results that you obtain. So if you get your results wrong, for example, your code is wrong, so just comment from your results. Maybe the graph for S is higher than in question A compared to question C because of blah 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 blah. You merepek yang logik lah, okay? Jangan merepek yang macam tak common sense macam tu. I think macam tu kot. Okay, so if you have any question, you can ask me before test lah, of course. So esok pukul 8, sejam 45 minit, 15 minit masa untuk hantar. So pukul 10 tu habis lah. So make sure try to submit before the deadline, okay? Kalau hantar lambat, selalunya kena tolak markah. Okay, and jangan post soalan dekat chat, okay? Sebab fakulti dia orang dah buat something untuk beli sebahagian daripada akaun dalam chat, so dia orang boleh check siapa yang submit dekat chat, so dia orang boleh ambil tindakan siapa yang submit dekat chat, okay? So be careful sebab fakulti memang dah strict dengan siapa yang post soalan dekat chat, okay? Okay, so that's all for today's class. So see you guys tomorrow, okay? If you have problems siapa yang tersekat dalam banjir ke, let me know, okay? So that's all for today. Assalamualaikum. Bye bye. Nak tanya apa? Zaim.
Waalaikumsalam, sir.
Baru bangun tidur
Sakit.
Sakit? Sakit apa?
Sakit.
Mana?
Ada oh.
Zaim, okay tak? Okay, that's all for our class. So see you guys tomorrow. Assalamualaikum and bye.
Waalaikumsalam, sir.